Okay, hi everybody. So I'm going to talk about BDD, and the reason is I've worked in a couple of places where I've used it, and to be honest, I loved it. So before we go on what I'm going to cover, I just want to get an idea of the room. So if you could put your hands up if you have adopted TDD where you work or you understand what it is. That's TDD. What about BDD? Okay, so yeah, so not a lot of people. So we're going to first start with an overview of test-driven development. The reason is BDD is just an extension of TDD. It's not a replacement. Then I'm going to walk you through some results from a TDD study. So what are the benefits of adopting TDD and then extending that with BDD? Then I'm going to give an overview of behavior-driven development and the language that it uses, which is Gherkin. And then Vara, assisting me, is going to give a great demo on Nightwatch.js with Cucumber. It's brilliant. If you get the chance after this, go download it. It's really easy to use, and it's a lot of fun, to be honest with you. Okay, so let's start with TDD. So the first thing, so TDD is more of a development approach, and it's some principles and the way you are going to develop your code and what you do when you get your requirements. So the first thing a developer does when they're doing TDD is they write a test that fails. They don't even start writing any code. They just want to write a test that will fail, that they can repeat as they start writing the code for that feature. They get to a point where they pass. So they've now written the feature, they've written the code to satisfy the test they started with at the beginning, but they've still got to refactor their code. So the key thing is, it's about writing code to pass the test initially. Afterwards, it's about refactoring your code, tidying it up, making it more efficient. And then, to be honest, the reason why you refactor a lot of the times is you might be making a small change to a feature, but someone else's code is in there, so you'll go and tidy up their code, so you're always improving the code base underneath. Right, okay. I didn't know my mum would be watching on Facebook, so my wife sent her the link, so yeah, I'm going to be in a bit of trouble for this. So as a real-world example, I take the mum's test. So you sat in the lounge, your mum turns to you and she goes, "Go tidy your room." The first thing you do, you know it's not tidy, you say, "It's tidy." She goes marching upstairs, and then you bell her down, go, "Get up here and tidy your bedroom." So you march upstairs and you go and tidy it. You failed the test instantly. And you know what you do? You tidy it a bit and you go, "Mum, it's tidy." She comes back up and goes, "You haven't done that bit yet." So you're constantly trying your luck, and eventually your bedroom's tidy. Brilliant. And then you've got to refactor it, which is something I didn't do, which is taking all the stuff you put under your bed, into your cupboards, into your drawers, and tidying up the underneath. So that's the basis of TDD, really, and that's known as Redgreen refactoring. So it forces the developer to start thinking about testing at the beginning rather than the implementation of the feature that they've received in a requirement. So not only do they just think about testing, but they think about how I can test. So writing a piece of code isn't just about delivering the feature, it's writing it in the best way so you can test it. And I'm sure you can all sympathize with that, because the amount of times you come to test something and it's untestable because you've not been involved from the beginning to add testability to that feature. So I wanted to put it into context because, you know, it does take some additional time. So Microsoft did a study on TDD back in 2008, 2009, and they took 4 of their internal teams. So they took the Windows team, they took the MSN team, the Visual Studios team, and the IBM drivers team, and they said, we're going to study the effects of TDD and see whether it gives us any benefit. So there's lots of things they measured, lots of different metrics. They really went down to a huge amount of detail to understand the skills of the team, how much legacy code they had. So this wasn't just, let's run it and let's find out whether it works. They really tried to understand what the team looked like before. So the first thing they measured was, how long does it take us to do TDD? You know, they're doing testing up front now. Chances are they're going to do more testing than before. So it's going to cost more money. So they found overall it was around 25 to 35%, 15% to 35% extra cost. So that figure is, if I get a new feature as a developer, it's going to take me 15 to 20 to 35% longer to do that. But they also measured the defect density, and that is the amount of defects that they find per 1,000 line of code. Okay, so who thinks the defect density was reduced by 0 to 30%? Put your hands up. You've got a lot of faith in this then, yeah? Because 30%'s a lot. Okay, ooh, wrong way. Who thinks it's between 30 to 60%? Okay, makes sense, it's in the middle. Who thinks between 60 and 90%? We won't think 100, but yeah. So it is between, on average, 60 to 90%. And that isn't just what they find in development, that is before they release, and they measured the amount of defects after they release. Now you notice the IBM drivers team had a little bit of a wobble compared to everyone else. Don't blame IBM, it's an internal team. And they had a lot of legacy code to deal with at the same time. So they were different than these other teams. They found when they took up a new feature for the first time that they averaged 60 to 90%. So what they also concluded was that the savings they made by dropping defects by such an amount more than made up for the time it takes to implement TDD. So you've got the instant benefit. Yes, you've got an upfront cost, but long term you'll save, because you've got to remember the reputational damage of a defect when it goes live. It's not just how many we find, but that defect could wipe X amount of revenue off your balance sheet for the year just because you've upset a certain percentage of customers. So what is behavior-driven development? So it's an extension of the techniques and principles of TDD. It is just an extension. If someone tells you BDD is better than TDD, ignore them. They are wrong. It is simply an extension. You have to understand TDD before you go and start learning about BDD. And it's an outside-in approach. So a developer will get a requirement and they often think, how am I going to implement this feature? Well, the difference with BDD is everything's written on the basis that you're describing the behavior of the application. So you're looking from the application from the user's perspective, from the outside in. Nothing from the requirements gathering phase is written in a technical manner. It utilizes a simple domain-driven language called Gherkin, which I'll describe a bit later and show some examples. And Gherkin uses three main things, which is given, when, and then. So given is the context. You're framing the context of the feature. When is the event, that's the action, that's what the feature is going to do. And then is the outcome of that event. Okay? Really simple to understand. Really, really simple. And this is sort of subject to some debate. It can be used in several areas, not just requirements gathering. So people think you should always maintain it as outside in, always keep it based just purely on the behavior of the application. I disagree. I think you can expand on that with your technical implementation and still use Gherkin. And I've seen it done, so I know it works. It worked for us. And then further with your tests. You just reduce the domain of people. You just reduce the audience, that's all. And the primary purpose is to reduce complexity and increase communication and understanding. That is the primary reason for BDD. I think it was Dan North invented BDD, and he did it out of frustration with TDD. He wanted to be able to have an easy to understand conversation with the customer and build the requirements based on the behavior of the feature that he was going to code. And he's quite open to the interpretation of BDD, which is great. He likes to see people using it in different ways. But communication is key. It's the one thing. So poor communication leads to failure. In my opinion, the worst defects I've had is when you've had a misunderstanding of the requirement that the business has said, or that you've misunderstood the design, and now the defect's in live. It's not only is it a defect, it's not what they wanted in the first place. So a little example is, let's take Jules and Brett. So Jules and his boss hired Brett, and they gave them simple instructions that they thought Brett understood. And then even afterwards, when he failed to do so, when asked a simple question, he couldn't answer it. The communication had completely broken down. And, well, unfortunately, we know what happened to Brett. My son does know what Pulp Fiction is, but I made him get out of my room when I decided to rewatch it last night. Okay. So how do we solve this problem? So I'm going to give a few examples. So here's an example of a requirement. The website must have a login page which allows the customer to log into their account. I'm sure we've all seen one-line requirements like that, yeah? Hands up if okay. They don't really explain a lot, so you have to make a lot of assumptions or have a lot of discussions with the business user or the BA. This is how we'd write it in Gherkin. So first we describe the feature, account login, and we just very basically say, in order to log into my account as a customer, I want a login page. So it's a simple interpretation of the requirements. But then we'd start writing our scenarios out for that feature. So scenario 1, customer login. Given that a customer has an account and that the customer is not currently logged into their account and the customer is on the account page, I'm setting the context of this feature. When the customer enters valid login details and selects login, that's the event, that's what the actual user's going to do, then the customer will be logged into their account. It seems really simple, and it is just a different way of writing a requirement. But the benefit is, it's driving out the behavior of the feature, and there's lots of nice frameworks and stuff that you can do with it. People will often say the frameworks are the best part. I think it's the language. Now, design is a bit of a difficult one. So again, as I said previously, that it's an outside-in approach, so it shouldn't go too technical. I think you can. So let's take an example of the developers put a massive, big, great spreadsheet together which describes all the errors that you can experience at login. Well, you can put that into Gherkin as well. So given that a customer has an account and the customer is on the account login page, when the customer login results in the following error, and notice I'm not describing the error there because I'm going to show you something else, then error ID will be logged in the error table. And the reason why we've got error ID and error there is we can then use examples below to fill in the gap. So that is essentially the representation of the Excel spreadsheet. That stops us from writing loads and loads and loads and loads of scenarios. We can just reference the table below, and the frameworks will understand that as well, so you don't have to keep repeating yourself. So you reduce duplication. And then tests, which is us, and that's just as important as well. So I wrote out some steps. It's a representation of QC or something like that. So here they're trying to test the invalid login for a username. So let's say I use special characters, I don't have an @ symbol. So again, you write your tests in Gherkin in exactly the same way. Given that a customer has an account and the customer is on the account login page, when the customer logs in with the invalid username, again, username, then the customer will be presented with the warning, your username is invalid, followed by user warning. So that will be your test that you write. So what you're seeing here is you're using the same language at requirements gathering, the developer's using the same language, and you are. All of a sudden, you reduce the barriers to communication between teams. You're all discussing the same thing. You can go to a customer and they can go, show us how you've tested this, which is a really awful question to get because they never understand. But they will in this context. Sometimes it'll be too complicated for them to understand, but you're building up a lot of collateral that is just in plain English. So what else? So a couple of additional things you can do. So tags. So you can put tags on your features and tags on your scenario. So you know when you build an automation pack and you want to organize it? Well, here you use tags to do that. So you'll put tag regression or tag smoke test or tag category A, and then you'll run those using the tag. So you're actually putting the grouping in. It's like Twitter, essentially. Background. So you can also set a background to your scenarios. So that's further expanding on the feature so that the scenarios do the least amount of steps, so you don't have to keep repeating. So your framework will look at the background and then just keep executing the tests that are for a few steps in a scenario. There's a wide range of frameworks available. I know some people at Shop Direct to be looking at JBehave, is it, Nigel? Is that the one you're looking at? JBehave and Aiden? Yeah. But you've got SpecFlow, and that's for a .NET environment. A lot of people use Cucumber if they're developing in Java. Bhat. I'd never used that. I found that on Google. But again, just going back to my original point, it enables a common language, and it's such a simple thing to think a common language. But for me, you know, when I've worked in BDD, I honestly believe we saw less issues because we were all talking the same language. I know there's a couple of people in this room that worked in the environment where we were using BDD, and I thought it was great. And they're nodding there, so I guess they agree. Okay, so I'm going to give you an overview of Nightwatch, and then we'll do a live demo. So it's an open source automation framework for browser-based testing. It's based on Node.js, so you get, you know, lower I/O overhead, so it's really good. It's easy to understand syntax, which uses the Selenium WebDriver API. Little coding knowledge required. So a lot of web companies will probably use Java with Selenium, and they'll code stuff up. Nightwatch is great because it's got an API library written in plain English, and pretty much anyone with hardly any coding experience can automate. So I installed Nightwatch, and I think I was running my first Google test in about 10 minutes. You know, I think you were looking at Nightwatch, it took you about an hour, didn't you, just to write a complex test. It's really powerful. Because it's based on Node.js, it's asynchronous as well, which is really, really important. So if I've got a test with 5 steps, I start running the first test, which is checking a database, and only the last test is dependent on that first test. It'll continue running those other tests. It doesn't have to wait for the query to be returned back from the database to carry on. So it's a real big advantage, and you can do it over multiple browsers and run tests all over the place. And it can be implemented with Cucumber to use Gherkin and feature files. That was a massive pain in the arse. I think it took us about 2 weeks. So there is something on Git which you can download to use Nightwatch with Cucumber. It took us an age to troubleshoot because the instructions aren't very good. We will be writing our own and putting it up because we've gotten it to work, and we'll follow up with a video. So I'll try and get that posted on the meetup. So if you're interested, you can get a nice, easy to understand video to install it. Okay. This is a principle of most stuff that you use with BDD, but the first thing you do is you write a feature file. It's like a text file. You can use Notepad, whatever, and you just write the feature in plain text, as we described before. You just save it then as .feature, and that's how the frameworks will understand. As you can see, we've got a tag here for our smoke test, and we're testing one of the best retail sites in the country, which is that's a Shop Direct website. Yeah, there you go, right at the back. So the scenario is we go to the home page and we search for shoes. In this test, we've got 2 scenarios. And you might notice when we search for shoes and we're trying to assert that we're on the shoes page, we're actually going to check whether we're in the electrical section. That's because I wanted to show you a test failing on the report, because it's quite cool. Good jeans now, jeans feature file. And then we've got the jeans feature file. It does the same thing, but it just searches for jeans, okay? So 2 feature files. You can't have multiple features in one feature file. You can have multiple scenarios for a feature in a feature file. So you write your features up, nice, easy text files, and then you write a steps definitions file. So if you click that, Laura. So this is, so how does a framework know what to do when it gets to the website? How does it know to go places and check stuff? So that's the step definitions file. It looks a bit complicated, it's not really. So when you actually write your feature files, you can run it, and it gives you all your steps in regular expression, so a unique name. So it'll give you that automatically. So what that means is, if you add another feature file later, and then you run it, it'll tell you all the stuff you've already written code for to do that test. You don't duplicate. And then it will actually throw a report out to tell you that it's pending, and then you go back, you write the steps to cover the ones that you hadn't got, so you don't you're only reusing the same code. So below here is the night watch bit. So it's as simple, to go to the website, it's as simple as writing .url and then writing very.co.uk. Wait for element to be visible, so that's just a timing to wait for the website to come up. And then you can assert the title as well, and use, I think that references the actual feature itself. Yeah.
The title that we pass through the feature file.
Yeah.
So in the feature file, if we change the title, that the script is not hard coded. So
exactly. Yeah. Yeah. So when we put this on Git, we'll include all our example files as well, so you can run those through and reuse them. So we've got our two tests, and one was smoke, I think a smoke test tag, and the other one had something else. So Vara, do you want to kick off the test? So this is run via command line. You might use some build tool like Jenkins or something like that to kick this off after your build is run. And what we're going to do is we're just going, and it's just from a normal terminal, we're just going to run night watch for the, which tag is it?
Smoke.
Smoke. So what that's going to pick up, I think, is it jeans?
It's going to pick up jeans and shoes.
Yeah. Both of them?
Yeah.
Okay.
Change it.
No, it's okay. We'll run both. So we're going to now. So by doing that, the runner is going to look through all your feature files and establish which one's got smoke as its test, and it's just going to run those. And what Nightwatch is doing is it's using the Selenium WebDriver API to send instructions. So as soon as he runs this, it'll boot up Selenium WebDriver and start sending the instructions through. That's brilliant. So this bit I really, really like. So you know you've written all that. Can you go back to the terminal bar? You know you've written all that code with .url. Well, the framework actually even describes your code in simple, plain language. So if you scroll up to the terminal, don't worry, it's meant to fail. That was the last test we wanted to fail. If you go down a bit, there you go. Where is it? Yeah, that's it. So you see where I said go to the .url very homepage and then assert the title. Given I open the very homepage, it's actually testing if the page title equals. So it's looking at the fact that you've said assert title, but then giving you back the English version of that code. So not only are you describing stuff in Given, in Gherkin, the framework's actually giving you the simple English understanding of the functions that you've invoked, which is great. But one of the brilliant things about this is the report. So if I can get you to open up the report. So you know we started, and if you collapse it all down, we started. So open the report and then collapse all the, yeah, that's it, collapse all these down. So we talked about the common language that we use across requirements, design and test. Well, now all our reports can reflect that common language as well. So it tells you exactly what is passing and what is failing, but in a really easy to understand context. So imagine you're a test manager and you don't really know much about the website, as some test managers do. I wasn't talking about you, Lee. So you can open this report and then you can see, okay, when it tried to assert the title, electricals, it failed. And then it'll take a screenshot for you as well, automatically. I personally love this report. I think it's brilliant. It's probably one of the things that first attracted me to the stuff on Git that I saw. And then it'll give you a summary of not only what features have passed and failed, but how many scenarios. And this will keep generating as your test running, so you can go back and check halfway through and then stop your test. But at the same time, it's generating XML in the background. So if you want to link it up with a build tool and get lovely, nice reports a different way you can, it'll have all this information in it. And that's it. That's my talk on BDD. and my watch. Thank you very much.